Hi, friends. Welcome to our lesson. I'm Mrs. Gradney, and today in our lesson, we'll continue creating equivalent fractions using the area model and multiplication. Let's get started. Let's start by thinking about what we already know. In our last lesson, we created fractions that were equivalent to unit fractions by doubling, tripling, or quadrupling the number of units in a whole. So let's start by drawing an area model to represent 1/3. Pause the video here and draw and shade an area model to represent 1/3. Don't forget to label the whole, and I'll be here waiting when you get back. Welcome back. Here's my area model showing 1/3. Did you remember to label the whole? If not, make sure that you do that. And also, remember, as we draw our area models throughout our lesson today, try to make your units as equal as you can, but they don't have to be perfect. Now, let's quadruple the number of units in the whole by drawing 3 horizontal dotted lines. Now, when we drew those horizontal lines and decomposed the thirds, what happened to the size of the fractional units? Right, the fractional units got smaller. This is the size of one of the thirds that we started with, and this is the size of one of our new fractional units. When we decomposed the thirds, what happened to the number of units in the whole? Well, we started with 3 units in the whole, but when we decomposed the thirds, now we have 12 units in the whole. So the number of units in the whole quadrupled. We got 4 times as many units in the whole. What about the number of selected units? In the beginning, we had 1 unit selected, but when we decompose those thirds, now we have 4 units selected. So the number of selected units also quadrupled, or got 4 times as many. So what two fractions is our area model showing our equivalent? Our model is showing that 1/3 is equal to 4/12. Great. Now let's show what happened to the units using multiplication. We started with 1/3. In the beginning, we had 3 units in the whole. But when we decomposed those thirds, we got 4 times as many units in the whole. Now we have 12 units in the whole. In the beginning, we had 1 unit selected. But when we decomposed the thirds, we got 4 times as many units selected. And now we have 4 units selected. So we've shown with multiplication that 1/3 is equal to 4/12. Now this is what we already know. Creating an equivalent fraction for a unit fraction using the area model and multiplication. But what if we wanted to create an equivalent fraction for 2/3? How would that thinking be the same and different? Let's try it out. Pause the video and draw and label an area model to show 2/3 this time. I'll be waiting when you get back. Welcome back. Here's my area model showing 2/3. We can see that the entire rectangle represents one whole and the fraction 2/3 is shaded and labeled. Now, what if we wanted to rename 2/3 using 4 times as many units? What could we do? Pause the video and talk out your thinking, and then try it. Draw horizontal dotted lines in your area model to make 4 times as many units. You'll be able to check your work with mine when you get back. Welcome back. Here's my area model showing 4 times as many units. To show 4 times as many units, we needed to draw 3 horizontal lines. Now, when we drew those horizontal lines and decomposed the thirds, what happened to the size of the fractional units? Right, the fractional units got smaller. This is the size of one of the thirds that we started with, and this is the size of our new fractional units. What happened to the number of units in the whole? Well, we started with 3 units in the whole, 3 larger units. And when we decompose those thirds, now we have 12 smaller units in the whole. So the number of units in the whole quadrupled. We got 4 times as many units in the whole. What about the number of selected units? In the beginning, we had 2 selected units. But when we decomposed the thirds, now we have 8 smaller selected units. So what 2 fractions is our area model showing our equivalent? Our model is showing that 2/3 equals 8/12. Now, how could we show what happened to the units using multiplication? Pause the video and talk out your thinking, and then give it a try. Write the multiplication sentence you're thinking of, starting with 2/3 equals. When you're done, come on back and you can check your work with mine. Welcome back. Here's how we could have written our multiplication sentence to show that 2/3 is equal to 8/12. We started with 2/3. In the beginning, we had 3 units in the whole. When we decomposed those thirds to make smaller units, we got 4 times as many units in the whole, and now we have 12 units in the whole. In the beginning, we had 2 selected units. But when we decomposed those thirds and made smaller units, we got 4 times as many units, and now we have 8 selected units. So we've shown with multiplication that 2/3 is equal to 8/12. Now, how can we be sure that 8/12 is still representing the same amount? Pause the video to talk out your thinking. I was thinking, we know the fractions represent the same amount because we didn't shade any more in the whole. The same amount of the whole is still shaded. Now we have more smaller units instead of the 2 larger units, but the selected area of the whole is still the same. Now, how is this problem related to the last problem we did, where we found that 1/3 is equal to 4/12? Pause the video to talk it out. Maybe you're thinking that if 1/3 equals 4/12, then it makes sense that 2/3 would equal 4/12 plus 4/12, or 8/12 in all. Or maybe you were thinking that in both problems, we quadrupled the number of units in the whole. We renamed thirds as 12ths, but we just had a different number of selected units in each problem. Great thinking. Let's try some true or false. Read this number sentence. 3/4 equals 6/8. Now, if the wholes are the same, is this number sentence true or false? And how do you know? Pause the video to figure it out and explain your reasoning. Maybe you reasoned that 3 times 2 equals 6 and 4 times 2 equals 8. So this number sentence is true. Both the number of units in the whole and the number of selected units have been doubled. Pause the video now and represent the equivalence of these 2 fractions with a number sentence using multiplication. Then confirm your thinking by drawing an area model. When you get back, you can compare your work with mine. Welcome back. Here's my number sentence using multiplication and my area model showing the equivalence of 3/4 and 6/8. Compare your work with mine and make any changes if you need to. Let's try another one. Read the equation. 3/4 equals 6/12. Now, if the wholes are the same, is this equation true or false? And how do you know? Pause the video to figure it out and explain your reasoning. Maybe you're thinking, oh, this isn't true, because 3 times 2 equals 6 and 4 times 3 equals 12. So the number of units in the whole is being tripled and the number of selected units is being doubled. The numerator is being multiplied by 2 and the denominator is being multiplied by 3. We know that if we're creating an equivalent fraction, then we have to multiply the numerator and the denominator by the same number. So 3/4 and 6/12 are not equivalent fractions. This is false. Pause the video and change the right side of this equation to make it true. So keep 3/4 and then change either the numerator or the denominator in 6/12 to make it an equivalent fraction to 3/4. When you get back, we'll compare our thinking. Welcome back. We could have renamed 3/4 as 6/8 because then both the numerator and denominator would be multiplied by 2. We would be doubling both the number of units in the whole and the number of selected units. Or we could have renamed 3/4 as 9/12 because then we would be multiplying both the numerator and the denominator by 3. We would be tripling both the number of units in the whole and the number of selected units. Which way did you choose? Both ways are correct, and both ways create an equivalent fraction for 3/4. Great thinking. Now let's think about how we can create an equivalent fraction without having to draw an area model first. Think about what we've done in our lesson today. How would you explain to a friend how to create an equivalent fraction without having to draw an area model? Pause the video to talk out your thinking. In our lesson, we've doubled, tripled, or quadrupled the numerator and the denominator. We've multiplied the numerator and the denominator of a fraction by the same number to create an equivalent fraction. So pause the video and create an equivalent fraction for 3/5 using multiplication. You can check your work with mine when you get back. Welcome back. Here are some of the ways that you may have created an equivalent fraction for 3/5 using multiplication. Do any of these look like how you thought about it? Let's read the equivalent fractions. 3/5 equals 6/10. 3/5 equals 9/15. 3/5 equals 12/20. 3/5 equals 15/25. Now, of course, these aren't the only correct equivalent fractions for 3/5. How is it possible that 3/5 has so many different equivalent fractions? Pause the video to talk out your thinking. Hopefully you said something like, we can decompose 3/5 in lots of different ways. We can decompose 3/5 by doubling the units, or tripling the units, or quadrupling the units, or even getting 5 times as many units. So there will be lots of equivalent fractions for 3/5, but they all represent the same amount. We just have different sized units. Excellent work today, friends. I think you're ready for the problem set. On the screen are the